Hey, this is Kylie, and I'm going to teach you about two variable inequalities. Again, yay, with the happy face. Okay, so like in my last video, I had the vocab. Thankfully, there's only one this time. So we have linear equality, which is just like an equality with two variables whose graph is a region of the coordinate plane that is bounded by a line. So literally, like the whole entire thing with y is greater than or less than or equal to, like that, or x, like that. That's mainly what we're working with. So for an example, here's like simple example Facebook, and we're gonna do this. So I wrote I put down that y is greater than 2x minus 6. So here I have you just like how when you do a regular function and you just like graph it, yeah, you do that, but then because we have like this inequality symbol, you have to shade in like the parts. So this is a greater than symbol, and it doesn't have like the equal sign, so it's going to be a dotted line. So like greater than or greater than or less than signs, they are dotted, but then when they're greater than or equal to, or the less than or equal to sign, for example, let's do this one. Y is the negative is less than or equal to negative 3x plus 2. So y is less than or equal to negative 3x plus 2. So like a regular function, you graph it, but then see how this is different. This is more of a solid line because this is the sign is different. So that's one big thing you should learn about this. We're going to apply what we learned to a real life situation. So here's the question. At least 35 performers of the Big Tent Circus are in the grand finale. Some performers pile into cars while others balance on bicycles. 7 performers are in each car and 5 performers are in each bicycle. Draw a graph showing all the combinations of cars and bicycles possible for the finale. Sorry, not a question, but rather a statement. So right now we're gonna allow x to equal the amount of cars and y equal the number of bicycles. And then here's the equation: 7x plus 5y is greater than or equal to 35. So I went to Desmos and I put this in. I had trouble putting in the hold on. I apologize. Where you can never have negative performers, so we're gonna have to find the intercepts. So we all know how to find intercepts, hopefully. So if not, just have some variables equal to 0 and you can find them. And I went to Desmos and I put this in. I had trouble putting on limitations. So just imagine that there's a point over here, and a point over there, and then all the shaded parts over here do not exist. They don't exist. So these are all the possible combinations. Delete this. Don't pretend it's not there. It's invisible. Here, there, from 0 to there. Pretend it's invisible. These are all your combinations. And that's this yeah, we're gonna just apply everything together now. So right before, let's have example: y is less than or greater equal to absolute value of x minus 4 plus 5. Now let's plug this in. Delete this. Deleting. Okay, y is less than or greater to than equal to whatever thingy. Absolute value of x minus 4 plus 5. Yay! Okay, so first of all, let's see y. So we know that the graph moves over 4 units to the right because of what we learned last section and how the graph moves this way because because it's in the absolute value, and then it goes up 5 units because it's plus 5. And then by applying what we learned, this is the greater than or equal to sign, so we know it's going to be a solid line, and since it's less than, it's going to be shaded down, showing that it is less than. And that is one example of how to solve or graph an absolute value inequality. Now let's do another one, erasing. Yeah, let's do a different color. Let's do that indigo blue color. Let's do this. Negative y plus 3 is greater than absolute value of x plus 1. So with the new one, we're gonna put, so rewriting the question, y plus 3 x plus 1. Yeah, different color now, purple, if that does make a difference. We're gonna solve for what we need to have y by itself, so we're gonna solve, so minus 3, so negative y is less than or equal to, or just less than absolute value of x plus 1 minus 3. Now we're going to divide it all by 3, or divide it all by negative 1. Yes, divide by negative 1, divide by negative 1. We're going to end up with y is less than negative value of x plus 1. Wait, yes, plus 3. So this, graph this, yeah. So deleting, y is less than or equal to negative absolute value, nope, negative absolute value of x plus 1 plus 3. And here we are. Again, with our symbol, it should be a dotted line, and showing that it is less than, it's going down. Yeah. And so this is how you graph absolute value inequalities. The families of functions and the inequalities, two variable inequalities. Thanks for watching.